afternoon, students. Today we are discussing about the exercise 8C, that problem number 10 is over, that is problem number 10. What is that? Limit extends to 0, x into e power x minus 1 by 1 minus cos x. See the solution here. What is given here? Limit extends to 0, x into e power x minus 1 by 1 minus cos x. So see here, limit extends to 0, x into e power x minus 1 by 1 minus cos x means what is the formula? That is 2 sin square x by 2. Now here, limit extends to 0, x into e power x minus 1. This is multiplying and dividing with 1. So then what? 2 sin square x by 2. Now see here, limit extends to 0, e power x minus 1 by x into what? X into x, what? That is x square by 2 sin square x by 2. See now, so this is equals to limit extends to 0, e power x minus 1 by x. Here 1 by 2 is constant, then x square goes down, then x square. Here this is multiplying and dividing with 1 by 4 into what? Sin square x by 2. Sin square x by 2. Okay, this is x square. Now here, so now this is 1 by 2 into limit e power x minus 1 by x is nothing but 1. Then what? X square. Limit extends to 0 here. And then what? X square by what? Sin square x by 2. This is multiplying and dividing with what? That is x square by 2 or x by 2 whole square. Limit what? That is extends to 0. So now what we are getting here? See, so now this is equals to 1 by 2, limit extends to 0. Here what? That is sin x by x is nothing but what? That is 1. And x square into what? That is x square by 4. X square by 4. X square gets cancelled, then 4 by 2 into limit extends to 0, that is what? 1. 4 by 2 means what we are getting here? 2 we are getting. So this is our required answer. See now, take is that once again this problem. Limit extends to 0, x into e power x minus 1 by 1 minus cos x. Limit extends to 0, x into e power x minus 1 by 1 minus cos x. Limit extends to 0, x into e power x minus 1. Now what is the formula here? 1 minus cos x is nothing but 2 sin square x by 2. Limit extends to 0, numerator is multiplying and dividing with x into here 2 sin square x by 2. Limit extends to 0. E power x minus 1 by x into x square. 2 sin square x by 2. Now here 1 by 2 is constant, then limit extends to 0. E power x square into e power x minus 1 by x into what, that is sin square x by 2. Now here 1 by 2 limit extends to 0. X square by what? Sin square x by 2. This value is equals to what? 1. Limit extends to 0. E power x minus 1 by x equals what, that is 1. So then this the denominator is multiplying and dividing with what? X by 2 whole square. So now then this in which form? Again limit extends to 0. Sin x by x. Now this is also equals to what? 1. Now here what we are getting here? 1 by 2. Limit extends to 0. Now x square by here is in which form? 1. Means what? X square by 4. X square gets cancelled there. 4. 4 by 2 equals what? That is 2. We are getting. So that is our required answer. See the next problem. See the next problem. Number 11, that is limit extends to 0. Log of 1 plus x cube by sin cube x. See what is given here. Limit extends to 0. Log of 1 plus x cube by what? Sin cube x. Now here limit extends to 0. The numerator and denominator is dividing with x cube. Now sin cube x by x cube. Now this is equals to limit extends to 0. This in which form? Log of 1 plus x cube by x cube by what? Limit extends to 0. Sin cube x by what? X cube. So now what we are getting? See here. Then already we know limit extends to 0. Log of 1 plus x by x equals what? That is 1. This is one formula. What is second formula here? Limit extends to 0. Sin x by x. This is also equals to 1. Now here this is equals to limit extends to 0. This is what? 1 by this is also 1. 1 by 1 equals what? 1 we are getting. So this is our required answer. This is the next problem. Problem number 12. Limit extends to 0. X tan 2x minus 2x tan x by 1 minus cos 2x whole square. See here, limit extends to 0. X into what is tan 2x formula? 2 tan x by 1 minus tan square x minus 2x tan x by 1 minus cos 2x means what? That is 2 sin square x whole square. Already we know the formula, that is what? cos 2x equals to what? 1 minus 2 sin square x. Now minus 2 sin square x from this side plus 2 sin square x equals to 1 minus cos 2x. Now see here, limit x tends to 0. What we are getting common here? 2x tan x. We are getting common then 1 by 1 minus tan square x minus 1 by what? 2 sin square x whole square. Now see here, limit x tends to 0. 2x tan x into, take the LCM here, 1 minus tan square x. Now see here, 1 minus 1. Minus into minus plus tan square x by what? 4 sin power 4x. Now see here, plus 1 minus 1, x cancel here, limit x tends to 0. 2x into tan square x is nothing but tan cube x by 1 minus tan square x by what? 4 sin power 4x. Now see here what we are getting here. Two is constant, that is limit x tends to 0. Now x into tan cube x is multiplying and dividing with what? X cube. And next what? Into 2 by 4. See here, 1 by 4. Now 4 goes up here, C. Into what? 1 by 1 minus tan square x by, this term is multiplying and dividing with the x power 4. So now 4x power 4 into sin power 4x by x power 4. So now what we are getting here? See. Now here 2 into limit x tends to 0 into x, this value is 1. X into x cube is nothing but x power 4 into what? Limit x tends to 0, 1 by 1 minus tan square x by here 4 into x power 4, this value is also 1. Sin x by x whole power 4. Here we are applying the two formulas here, what that is limit x tends to 0, tan x by x equals to 1, and next what? Limit x tends to 0, sin x by x is also equals to 1. So now see, this is equals to what we are getting here. Now we have 2 by 4 into x power 4 gets cancelled into what? That is limit x tends to 0, 1 by 1 minus tan square x. 2 by 4 means what? That is 1. 1 by 2. Now x tends to 0 means what? That is x value is 0 and 0 is nothing but 0. Now 1 by 2 into 1, that is equals to what? 1 by 2. This is our required answer. This is also important problem. So now see, listen once again. This is what is given here. Limit x tends to 0, x tan 2x minus 2x tan x by 1 minus cos 2x whole square. Limit x tends to 0, x into what is tan 2x formula? That is 2 tan x by 1 minus tan square x minus what 2x tan x by what 1 minus cos 2x means what 2 sin square x whole square. Limit x tends to 0. 2x tan x are getting common, then 1 by 1 minus tan square x minus 1 by 2 sin square x whole square. Limit x tends to 0. 2x tan x. Now take the LCM, that is 1 minus tan square x. Now here 1 minus 1 minus into minus plus tan square x by 1 minus tan square x. 2 sin square x whole square means what, that is 2 square is 4 sin power 4x. Now limit x tends to 0. 2x into tan x into tan square x is nothing but tan cube x by 1 minus tan square x by 4 sin power 4x. So see here, 2 into limit x tends to 0, x into tan cube x by x cube into, this is multiplying and dividing with the x cube here into 1 by 1 minus tan square x by what 4 into the denominator is multiplying and dividing with what x power 4. So here also you have to apply the formulas here. Limit x tends to 0, tan x by x equals to 1, and the limit x tends to 0, sin x by x is also equals to 1. So what we are getting here, 2 into limit x tends to 0, x power 4 into 1, and here limit x tends to 0, 1 by 1 minus tan square x by 4 into x power 4. Now see, x power 4 gets cancelled here, 2 by 4 into, then limit x tends to 0, 1 by 1 minus tan square x. Now substitute in place of x, what is that? 0. 1 by 1 minus 0, that is 1 by 2 into 1 is nothing but what, that is 1 by 2. This is our required answer. See the next problem here. See now, infinite limits and limits at infinity and limits at infinity. See now, suppose limit extends to a, f of x equals to infinity, then limit extends to a, 1 by f of x means 1 by infinity is equals what? 0. And the second one, suppose limit extends to a, f of x equals to minus infinity, then limit extends to a, 1 by f of x means 1 by minus infinity. This is also equals to 0. Next third condition here, if limit extends to a, f of x equals to 0 and f is positive, f is positive in a deleted neighborhood, in a deleted neighborhood of a, then limit extends to a, 1 by f of x is equals to infinity. Next one, see if limit extends to a, f of x equals to 0 and f is negative in a deleted neighborhood of a, then limit extends to a 1 by f of x equals what, that is minus infinity. So these are some important points for infinite limits and limits at infinity. What is the first condition here? Suppose limit extends to a, f of x equals to infinity, then limit extends to a 1 by f of x is equals to 1 by infinity is nothing but 0. The second one, what? Suppose limit extends to a, f of x equals to minus infinity, then limit extends to a 1 by f of x means what, that is 1 by infinity equals to 0. See now 1 by 0 equals what, that is infinity, which cannot define. 1 by infinity means what, that is 0. See now the next part condition here, if limit extends to a, f of x equals to 0 and f is positive in a deleted neighborhood of a, then limit extends to a 1 by f of x equals what, that is infinity means 1 by 0 is nothing but infinity. The next fourth condition, if limit extends to a, f of x equals to 0 and f is negative in a deleted neighborhood of a, the limit extends to a 1 by f of x equals what, that is minus infinity. This is equals what, minus infinity. See the next one. These are some conditions, infinite limits and the limits at infinity. See now, what is that? Show that limit extends to infinity, 1 by x square equals to 0. See now, what is given here? Limit extends to infinity, 1 by x square. We have to take, that is substitute in place of x. What is that? Infinity square. This 1 by infinity square. See now, 1 by 0 equals to infinity. 1 by infinity equals what, that is 0. So now here 1 by 0 square. This is equals to what? That is 0. 1 by infinity means what, that is 0. 0 square is equals what, that is 0. This is about first one. Next, see the next one. Show that limit extends to infinity, e power x equals to infinity. See now, limit extends to infinity, e power x means what, that is infinity. E power infinity is nothing but what, that is infinity. This is about second one. Next, compute limit extends to 2, x square plus 2x minus 1 by x square minus 4x plus 4. See the solution here. Substitute in place of x, how much that is? 2a. Now 2 square plus 2 into 2 minus 1 by 2 square minus 4 into 2 plus 4. This is equals to 2 square means 4 plus 4 minus 1. Now 4 minus 4 to the 8 plus 4. Now here 8 minus 1 nothing but 7 by 0. Something by 0 equals what, that is infinity we are taking. And next see. Next problem number compute limit extends to infinity x square minus sin x by x square minus 2. See here, sin x lies between minus 1 to 1. This is the range of sin x. Sin x lies between what, that is minus 1 to 1. And next see here, minus sin x lies between what, same, minus 1 to 1. And we are adding with the x square. X square minus 1 less than x square minus sin x less than x square plus 1. So this is dividing with what? X square minus 2. X square minus 1 by x square minus 2 less than x square minus sin x square, x square minus 2 less than x square plus 1 by x square minus 2. See, this is denoted by some g of x, and this is f of x, and this is h of x. Now here what is g of x here? G of x equals to what, that is x square minus 1 by x square minus 2. That limit extends to infinity. Now see here, x square we are getting common, then 1 minus 1 by x square. Here also the denominator also we are getting common, x square, then 1 minus 2 by x square. X square gets cancelled. Now what is the limit here? It extends to infinity. So this is equals to, limit extends to infinity, 1 minus 1 by x square by 1 minus 2 by x square. So see here, extends to infinity, then 1 by x tends to what? 1 by infinity, means that is 0. And 1 by x square is also tends to 1 by infinity, means 1 by x square tends to, that is also 0. When x tends to infinity, then 1 by x tends to 0 and 1 by x square tends to 0. So what we are getting here, then 1 minus 1 by x square, that is tends to 0 by 1 minus 2 by x square, that is also equals to tends to 0. So 1 by 1 equals to, that is 1. The next see, what is h of x? Then what? Limit extends to infinity, x square plus 1 by x square minus 2. Now here x square we are getting common, then 1 plus 1 by x square. The denominator is also x square we are getting common, then 1 minus 2 by x square. X square gets cancelled. Then what? 1 plus 1 by x square, 1 minus 2 by x square. Now see, here also extends to infinity, means what, that is 1 by x tends to 1 by infinity, 1 by x square tends to 1 by infinity square. Means x tends to infinity means 1 by x tends to 1 by infinity means what, that is 0. And 1 by x square tends to, that is also 1 by infinity, that is also equals to 0. Now see here, substitute in place of 1 by x square, that is 0, 1 plus 0 by 1 minus 0. Now that is 1 by 1 equals to what? 1. See here, h of x equals to 1 and g of x equals to 1. See here, therefore g of x equals to 1, h of x equals to 1. Then by sandwich theorem, or squeezing theorem, by sandwich theorem or squeezing theorem, then f of x is equals to what? 1. So therefore limit x tends to infinity, x square minus sin x by x square minus 2. Now this is equals to what? 1 we are doing. So this is our required answer. So listen once again here. What is given here? Compute limit x tends to infinity, x square minus sin x by x square minus 2. Here sin x is lies between minus 1 to 1. Minus sin x is lies between minus 1 to 1. Now we are adding x square, means x square minus 1 less than x square minus sin x less than x square plus 1. This is dividing with what? X square minus 2. Means x square minus 1 by x square minus 2 less than x square minus sin x by x square minus 2 less than x square plus 1 by x square minus 2. This is g of x and this is less than f of x less than h of x. See Nizam, here we are applying sandwich theorem. G of x equals to what, that is limit x tends to infinity, x square minus 1 by x square minus 2. Now limit x tends to infinity, x square we are getting common, then 1 minus 1 by x square, the denominator x square we are getting common, 1 minus 2 by x square. Now limit x tends to infinity, 1 minus 1 by x square by 1 minus 2 by x square. Now see here, here x tends to infinity means what, that is 1 by x tends to 1 by infinity. Next one, 1 by x square tends to 1 by infinity. Now x tends to infinity means 1 by x tends to 1 by infinity is nothing but 0. Now 1 by x square tends to 1 by infinity is nothing also 0. So then 1 minus 0 by 1 minus 0. 1 by 1 equals what, that is 1 we are getting. Next take here h of x. What is h of x here? X square plus 1 by x square minus 2. In the numerator, what we are getting common? X square we are getting common. Then 1 plus 1 by x square. The denominator is also x square we are getting common. Then 1 minus 2 by x square. X square gets cancelled. Then 1 plus 1 by x square. The 1 minus 2 by x square. So see here x tends to infinity. Then 1 by x tends to 1 by infinity. 1 by x square tends to 1 by infinity square. Now x tends to infinity means 1 by x tends to 1 by infinity means what, that is 0. 1 by x square tends to is also 0. Now substitute in place of 1 by x square, that is 0. 1 minus 0. 1 by 1 equals what, that is 1. Here we are getting therefore g of x equals to 1, h of x equals to 1. Then by using which theorem here? By sandwich theorem or squeezing theorem, f of x equals to what, that is 1. F of x means what, that is middle value. What is that? The given limit x tends to infinity, x square minus sin x by x square minus 2 equals to 1. This is the sandwich theorem. When f of x, when g of x is equals to h of x, then that is equals to f of x. This is called as sandwich theorem or squeezing theorem.